What we're going to deal with now is what happens when we touch charged objects together. Right. So let's have a look at a situation. If I had a particle, and I want you to pay attention, I'll pack away your stuff. Stop pasting in, stop doing homework, you listen. Okay. You've got a particle which is neutral. Now, can anyone tell me what it means if a particle is neutral? It means that for every positive that it's got, and let's give it 4 positives, but it may be 4 trillion gazillion positives, okay? How many negatives would it have? It would have a negative to match and neutralize each one of those positives. Do you agree? Okay. Let's draw another particle next door to it. And that particle is negatively charged. What does that mean? Has it got positives? Let's give it its 4 positives. 1, 2, 3, 4. How many negatives must I give it? I must give it 1, 2, 3, 4. Let's give it another 5, 6. Do you agree? How many extra negatives has it got? 2. So we all agree that this particle is neutral. And this one is negative. All happy with that? We allow them to touch. And then we separate them again. What will the charge on each one be after they're separated? So they're allowed to touch. Bring them together. And then we separate them again. They'll both be negative. Which particles will want to move? Will these particles here want to move? Which particles can move? Which particles can't move? Protons. The positives can't move, the negatives can move. Okay, so you say none of these particles will move if they're given a chance? No. Will any of these particles move if they're given a chance? Which ones? The 2 electrons. Let's circle them, okay? So you agree that electron there and that electron there, if they're given a chance, will move. Why? What are they doing to each other at the moment? Repelling. They want to get as far away from each other as possible. The others all neutralize. So when I touch them together, they're both going to jump onto that one. One's going to jump on. Okay? So you say each one will still have its 4 positives. 1, 2, 3, 4. 1, 2, 3, 4. This one will still have its matching negatives with each positive. You agree? And the same here. Happy? But what else would have happened? There would be an extra negative left over here that didn't jump ship. And the one that did would be there. So what would the charge on this be? -1. And this? 1. Okay. Now, do you agree if I said to you, you have a charge of 3.68 microcoulombs and a charge of 4.21 nanocoulombs, they brought together, what will the new charge be? It's not quite so simple, is it? How do you work it out mathematically? Mathematically, you simply add their charges together. So, how would you do this? Mathematically, you'd say, what's the charge on the one? So really it's Q1 plus Q2 divided by 2 equals. That's what you do. What's Q1? 0. It's got no charge. You agree? It's neutral. Plus minus 2 divided by how many particles do they get shared between? 2 gives us minus 1 each. We're all happy with that. Do another example. A particle with a charge of plus 6 coulombs is allowed to touch another particle with a charge of minus 2 coulombs. What will the new charge on each particle be once they're separated? Okay, take that down. Let's do it now in class. Right, Luto, you've done one. Mika, will you tell me what to do here? You don't need a formula. No, just, can you see it? Okay, call out. Have you written it down yet? Will you okay, take it down quickly, finish doing what you're doing. Why are you only taking this down now? Yes, but it shouldn't have taken that long. You've only drawn 2 circles. Right, people, this is your homework along with that other last example, number 6. So your homework for Monday, I don't see you tomorrow, paste in all these 5 pages, do number 6, and make sure this is done all for Monday. Thank you very much. Make sure you've got it down before you go.